for quiz 6, our first problem is to write the coterminal angle for the angle 750 degrees, where the coterminal angle is labeled as theta, and theta has to be between 0 and 360, including possibly 0 or 360 degrees. So first of all here, remember whenever you're dealing with an angle, it's really rotating around a circle on the XY axis. So if we're doing that, if we have one rotation, then it'd be 360 degrees, and well, this is more than 360, so start out by subtracting 360 degrees, see where that leaves us. If it was negative instead of positive, then we would have added 360 degrees instead. Since it's more than 360, that's why we're subtracting 360. So if we do 750 minus 360, we get 390, which is still more than 360 degrees, so it's still not within the range that we're looking for. So we'll need to subtract 360 again. Or if you notice right away that it's going to be more than 2 revolutions around, then you could subtract 2 times the 360 degrees right away if you notice that. So then here in this case, we would get 30 degrees then for our angle, for our coterminal angle. And once again, that is then what our angle theta is equal to. And then that would be our final answer for the first problem. And then for number 2, I'm going to find sine, cosine, tangent of angle A for the next triangle, and we want to make sure to solve for our hypotenuse first. So remember, if you've got a right triangle like we have here, we'd have to use our Pythagorean theorem, a squared plus b squared equals c squared, to get the hypotenuse first of all. So in this case, we'd have our 5 squared, one of the legs of a triangle, plus 7 squared, another leg of the triangle, equals our c squared, which is what that hypotenuse is called. So here, if we go through and do that, we're going to get 74 there. If we do that 5 squared plus the 7 squared, because 5 squared is 25, and 7 squared is 49, and then we add those together. And then that's once again still equal to c squared. So then we need to do the square root of both sides to finish solving for our hypotenuse, our side c there. So in this case, our hypotenuse is equal to the square root of 74. And that square root is not going to simplify, so we'll leave it as is. Do not round it. We want to keep it exact, otherwise it's going to throw off the rest of your answers here. Because we want to keep it exact for this problem, because we'll also be using it for number 3 as well. So if we're figuring out sine of our angle A, we'd write that as sine of A. So we abbreviate sine, remember, as sin of A equals. And then it may be helpful to remind yourself what the acronym is that we can use here. So we'll write it off to the side here. We can use that acronym SOHCAHTOA to help us remember which sides to use. So remember, the SO part means sine is equal to opposite over the hypotenuse. The CA part means cosine is equal to the adjacent over the hypotenuse. And then the TOA means tangent is equal to opposite over its adjacent side. So for our sine of A here, we'd have our opposite side. So remember, that's going to be opposite of that angle would be 5 over the hypotenuse, which is what we just solved for. That's square root of 74. And in this case, this would be an exact form, or if you want, you can rationalize that denominator like I had you do in some of those exercises in the book. We'd have 5 times the square root of 74 over 74. by multiplying the top and the bottom of that fraction by the square root of 74 and then simplifying. Similar thing for our cosine. Cosine, we can abbreviate as COS for cosine of our angle A equals, and then we have our adjacent side this side time, which is our 7 there. So if we do that, we'd have 7 over, and delete that part first here. I accidentally marked the page where I didn't want to. So we'd have the 7 over the hypotenuse, which was that square root of 74. Or once again, you could rationalize that denominator like I have you do in some of the problems. For the classwork problems, we'd have 7 times the square root of 74 over 74. That's another way that you could write that. Either way would be fine for the quiz. And then for the last one here, for tangent, since I'm not having you go through and have to write out the secant, cosecant, and cotangent here, just the sine, cosine, and tangent, go a little quicker there. So tangent is opposite over the adjacent, so we'd have the 5 over 7. The side that was opposite of our angle A over the adjacent side. And that fraction cannot be simplified, so we'd leave that as is. And that would be your answer for that second problem. Like normal, the quiz will be similar to these, just different values. And then for the next one, find the measure now of angle A from number 2. So remember, if you're trying to then figure out what the angle measurement is from one of these, you have to do the inverse of that trig function. So in this case, I would choose the tangent one, because that'll be easier to plug into your calculator because we don't have the square roots involved. But you could definitely do inverse sine or cosine as well with whatever we had on the other side of that equation. So in this case, we'd have, if we use the tangent one, we'd have inverse tangent, which remember is that tan to the -1 is how that would show up on most of your calculators. Some of yours, it may show up as arctangent instead, just depending on how yours is programmed. So we'd have inverse tangent of 5 over 7. And this one you will need to round. There's no way of writing this at an exact form here, so we'll use the approximation sign. Be approximately equal to 35.54. And then make sure once again, include your units here, because we do have what the units would be. It'd be in terms of degrees since you're solving for an angle. And that would be for our angle A from that triangle in number 2. And then remember, whenever you're rounding, make sure to go out at least 2 decimal places. And then like I said, you could have used sine or cosine to do the inverse of as well. If you're doing cosine, it'd be inverse cosine of 7 over square root of 74. If you use the sine, it'd be inverse sine of 5 over square root of 74. No matter which one you choose, you should get the same answer for your angle A, assuming you do all of the work correctly. And then the last one here, number 4, I'm going to figure out the length. Well, actually, we're given the length of this isosceles triangle, and we're also given what the base angles are, so it might be helpful, first of all, to sketch this out. So we'd have the base of this isosceles triangle is 52 inches. And then we have what the base angles are, so in other words, what these angles are down here, which was 42 degrees. And then we're trying to figure out what the length of those sides are on the isosceles triangle. So we're trying to figure out the length of each of those 2 equal sides for that isosceles triangle. So both of those are the same because remember, isosceles triangles have 2 sides that are equal or congruent to each other. And we need to use law of sines or law of cosines. So normally you want to use law of sines when possible. a little bit easier to set up. So in this case, we could use law of sines if we figure out this top angle first. So remember, anytime you're dealing with a triangle, all of your angles add up to 180 degrees inside of a triangle. So to figure out that third angle, we can subtract from the 180 42 degrees for the first base angle and another 42 degrees for the second base angle there. So if we calculate that out, we get 96 degrees there. And then once we have that, we can set up our equation here. So whenever we're using this for the law of sines, we have A over sine of capital A, which means the side length, over sine of its opposite angle, and then equals, and then another side, which we'll call side B, over sine of its opposite angle. And we always have to have at least one of those sets where we're given all of that information to be able to solve this. So in this case, once again, we'll label this up here in the triangle, make it easier to see which ones are opposite of each other. We'd have that 96 degrees here is this angle. So the 96 degrees is opposite of that 52 inches for that side there. So those would be matched up as one of our pairs for our proportion here. So we'd have 52 over sine of 96 degrees equals, and then do a similar thing on the other side here. And it doesn't matter which one you pick because these are opposite of the same because it is an isosceles triangle. So you'd have x over sine of 42 degrees. And then like normal, anytime whenever you have a proportion, we want to cross multiply to solve this. There's definitely other ways to do it as well. This is typically the way that is easier for most students to understand. So if we cross multiply here, we'd have our 52 times the sine of 42 equals our x times the sine of 96 and it'd be helpful to wait until the very end if possible to go through and calculate it all out. Some of your calculators, you may need to break up the steps into multiple steps depending on how your calculator's programmed. But here then we can divide both sides by sine of 96. Make sure to include that sine function as well, otherwise you will get a totally different answer which will be incorrect there. So divide by sine of 96, because remember, anytime you have an angle, you always have to have a trig function matched up with it. And sine of 96 over sine of 96 is equal to 1. 1 times the x will leave us with just the x on that right hand side. It's like normal, anytime if you divide by a number by itself, you cancel that out. And then we can plug in the 52 times that sine of 42, and then divided by the sine of the 96 there. And then like I said, depending on your calculator, you may need to plug that in multiple steps there. Either way though, you should get the same answer if you plug it in correctly into your calculator. So if we go through and plug that in, we're going to get about 34 point, all right, write it down here, 34 point 0.99 approximately, looks like, if we rounded it to 2 decimal places, and that would be in terms of degrees there. So make sure, once again, anytime whenever you're going through and solving these, go at least 2 decimal places whenever you're rounding these. Your answer may be slightly different if your calculator won't do it exactly for all of those steps. Just depends on how yours is programmed, but make sure that you are showing all of your work, and make sure to ask if you do have any other questions like normal.